Okay, I'm going to show how to create a smiley face to be plotted on a two-channel oscilloscope just using an arbitrary waveform generator that's handling .csv files. So what we have here is just a spreadsheet, and column A is just the numbers 1 through 340, and so is column C. In order to do that, we can just drag that 1 that's in column C down to 340, and it adds all those numbers in to the column. Now I have a formula to create a semicircle here. It has the format of the square root of a squared minus x squared, where x is the x-axis. And in order to make this scale properly, I want to compute some values for the x-axis. So I'm going to take the numbers on the x-axis, which would be 1 to 340, and I'm going to divide them by 24 so that they're small enough to compute in this formula properly. And all I really need to do is drag this formula, which is taking column A and dividing it by 24 and subtracting 7. So here we just could copy that down, 340 lines, and so we now have all of our adjustments to the x-axis in column B. And now in the column D, I have a formula for a semicircle that uses the data from column B. And all I have to do to make that happen is drag it down, and it draws a semicircle. So I can make that look a bit more like a semicircle. I might have to adjust that later. So column E, I want to make the other half of this circle. So I'm just going to invert column D. So this is just minus D. And I'll copy that down. So now we have the bottom half of the circle, and let's just make it into a circle. Now, in order to plot this, what I need to do is have a single trace that just plots vertical lines on each point in this table. So I want to alternate a line going from the top half of the circle to the bottom half of the circle, and then back up to the top half and back down to the bottom, and just up and down all the way across. Now the formula to do that is pretty simple. So if the number in column C is even, I'm going to take the number from column D, and if the number is odd, I'm going to take the number from column E. And again, it's just a formula. I can copy it down, and what happens? It draws all the lines and fills in this circle. So now I have a filled circle that will show up on a scope as a filled circle. Now, if I want to turn that into a smiley face, I can just add some vertical lines in here to make it, in this case, just going to be a square eyes and so on. So here's what that looks like. And I've added some leader on the coming in and going out. So now we have the circle with some eyes and a mouth. Now you could do these with formulas, but I just, what I did was I copied two numbers, like say 3 volts and 4 volts, and I took that and copy that and just copy it to a number of lines down below by hitting enter. And now I have alternating 3s and 4s, so it goes up and down between 3 volts and 4 volts. So that's how I created those eye features. And then all we need to do is copy the column that has the circle, which is column E in this case. So we copy that to a new spreadsheet. So that's column E. And then I just save this as a .csv file, and I call that smiley1. And then I take column B, no, column B, which is the one with the features in it. So I inserted a column B so that it would, in this spreadsheet, be on top of the yellow. And you can see that it starts out at 2 volts, which is the 2s that are all down this column. And then it goes to its oscillations here, down here. So it's just oscillating to create those features. So anyway, copy this column B over to this sheet, which is now just going to be saved as a .csv file called smiley2. And then I just import those into the arbitrary waveform generator, and I have my smiley face on a scope. So we'll see what that looks like on a scope. And here's the smiley face that I put together in that spreadsheet, just displaying using the Digilent Analog Discovery 3, using both waveform channels and both scope channels. One waveform channel is just displaying the yellow circle, and the other one is doing the eyes and mouth. So here's something you don't see every day, a scope that can actually do graphics. And this is a little card running across the screen. It's generated on 2 channels of arbitrary waveform generator, and I'm just scrolling the screen. It's just amazing what this Analog Discovery 3 can do. I could have spent more time on the graphics, but this really demonstrates the principle. What fun! I never expected to be able to do this with the Digilent Analog Discovery 3, but here it is.